So in this video, I'm going to be looking at problems that involve inverse trig functions. You're going to need two things, have these two things handy. One of them is going to be the unit circle, a completed unit circle. And the other thing you're going to want to have is the worksheet, section 5.7. If you can print it, that'd be great. Otherwise, you're going to need to write down these problems on paper and work them out with me, okay? All right, so we're going to work through some problems involving the inverse trig functions. So I need you to remember a couple things. Remember when we had y equals sine x, in order to create the inverse of that function and have it also be a function, we had to take the sine graph, which actually goes on forever in both directions, and we had to restrict it so that we wound up having just a portion of it. Okay, we restricted the domain of the sine, and we restricted it to be where x was going to be between negative pi over 2 and pi over 2. Okay, and by doing that, we snipped a piece of that is now going to pass the horizontal line test. So when we find the inverse of this, the sine along with this restricted domain, we're going to have a function, okay? So y equals, let me get that. Okay, so y equals sine inverse, the inverse sine function, compared with the sine inverse. Want you to kind of remember how this works. So do you remember that with the sine graph, this is your angle. This was where you were thinking of that as being where the angle would be, okay? And then the y was the value of the sine of that angle, right? So the y was the value of the sine of that angle, right? So when you do the inverse sine function, what goes in as the input to that would be the value, and what comes out of it is going to be an angle, okay? So sine inverse of x, you should think of as the angle in the range from negative pi over 2 to pi over 2 with a sine equal to whatever x is, okay? All right, and it helps to think about this on a unit circle. So it helps me to think about that is that, oops, that's too thick. Let me see if I can make that thinner. It helps for me to think about that as being there. That's negative pi over 2 to pi over 2, okay? All right. All right, let me go ahead and jot down what you should think of. I won't go through the whole explanation, but when we're doing cosine, the inverse cosine function of something, okay, what you should be thinking there is that you're trying to find the angle, and on that we restricted the original cosine to be from 0 to pi. So when you're doing the inverse cosine of some value, you need an angle in the region from 0 to pi with a cosine value of x, okay? So that would mean that on the unit circle, we're talking about in the first or second quadrants, right? So this is the first or the second quadrant, and with sine, it was the first or the fourth, okay? Tangent was also first and fourth, okay? There we want an angle in the region from negative pi over 2 to pi over 2, but we can't include the negative pi over 2 and the pi over 2 because we have vertical asymptotes there. But we need an angle in that range with a tangent equal to whatever that x is, okay? So we're actually looking for that angle when we're doing these. Okay, and tangent is like sine. It's from the negative pi over 2 to pi over 2. Cosine is from 0 to pi, okay? And this would be the first and the fourth. But we can't be right at pi over 2 or negative pi over 2. All right, so let me show you how to think about this. So let's go to the worksheet now, and let's work through a few of these. Okay, so here's problem number 1 on the worksheet. I just want to do it on paper rather than the worksheet. Okay, so by the way, this notation, I should have mentioned this earlier. Don't let that notation fool you. Okay, note, sine inverse of x is not 1 over sine x. Okay, it's not cosecant x. Okay, that's really wrong thinking. This notation here is like in the precalculus algebra component when we use the -1 to represent the inverse sine. This is inverse sine. Okay, sometimes called the arc sine. Okay, it's not a reciprocal. Let me write that better. Arc sine. Okay, all right, not a reciprocal. Okay, and that's just like f inverse of x did not mean 1 over f of x. Okay, it meant the inverse of some function. It was the inverse of f, not reciprocal. Reciprocal of it. All right, so that's just something I realized I should have mentioned earlier. So you got to be careful about that. All right, so in other words, you don't think of this as 1 over sine of square root of 3 over 2. You don't think of it like that at all, okay? What you should be thinking about is I'm looking for an angle whose sine turns out to be square root of 3. So that's what you should be thinking. Angle whose sine is square root of 3 over 2. And you should be in radian mode on these, okay? You should be in radian mode. Okay, now we're going to do these without a calculator. We want the angle to be reported, if possible, in terms of pi, if it makes sense that way. Okay, you can use your unit circle to help you with this, but we're looking for an angle whose sine is square root of 3 over 2, and the angle we want to think about has to be between the negative pi over 2. So remember, you should be thinking this for the sine, and you're thinking about an angle between negative pi over 2 and pi over 2. So that's got to come into play. All right, so that's when you go to your unit circle, or can go to your unit circle. Okay, and you look for, we're talking about sine, so that means we want a y coordinate to be square root of 3 over 2, and we want to be looking somewhere in here, and there's only one. See, that's why we restricted the domain of the original sine function, is so the answer to this question would have only one answer. And we can see that it would be pi over 3. Okay? So your answer to this right here should be, let me put it in red, pi over 3. I'll do it down below. So sine inverse of square root of 3 over 2 equals pi over 3, okay? But this should be kind of your thought process. You should go to that portion of the unit circle to figure out, to find the angle that had the square root of 3 over 2 in the y spot, and you should be looking only in the first and the fourth quadrants, okay? All right, second question also involves sine. Question number 2 is asking us for the inverse sine of a negative 0.5. Okay. All right. Now, the values we have here are also in a right triangle, special right triangle. So sometimes I'll use special right triangles when I'm doing it, because I like both ways. I like unit circle and special right triangles. So like on number 1, sometimes I'll do this. I'll think about a 30, 60, because I recognize square root of 3 coming from a 30, 60, 90 triangle. So I think about 1, 2, square root of 3. And square root of 3 over 2, square root of 3 needs to be the opposite. So that would be the 60, okay, degree angle, which is what pi over 3 really is. 60 degrees is really pi over 3. So sometimes I can just look at this to get it. I wanted to mention that because I want you to think about it here. All right, so the 1/2 also comes from a 30, 60, 90 triangle if I wanted to look at it that way. 1, 2, square root of 3. 1 would be opposite 30 degrees. See where the 1/2, the 0.5 could come from? The sine of 30 is a half. Here's the deal though, okay? I need to report an angle somewhere in the first or fourth quadrants, and it has to have a negative sign. Okay, so the sine of 30 would be a half. Okay, but there's an angle in the fourth quadrant that would have the same reference angle. Okay, so this would be negative pi over 6. This would be 30 degrees or pi over 6. So negative pi over 6 has the same reference angle. So it would also have the value of 0.5. It's just that it would be negative since you're down in this quadrant. Okay. If you look back at the unit circle, you're looking for the sine, which is the y-coordinate, to be negative, have to be in the first or the fourth quadrant. So you had to be in the fourth to have the sine values negative. Okay. And look, you got to be careful. The unit circle says 11 pi over 6. But you need to report an angle between negative pi over 2 and pi over 2, okay? And so your answer isn't going to be 11 pi over 6. You need to think about this as negative pi over 6. This is negative pi over 4. This is negative pi over 3, okay? And then we'd be at negative pi over 2 right there. So that's really tricky, I think. So you got to watch it. So the sine inverse of negative 0.5 actually turns out to be, and you need to report back, an angle between in this region here. So you need to report it as negative pi over 6, not as 11 pi over 6. Okay? All right. All right, let's try a few more. All right, so here is cosine inverse, and it's 1 right there. Ooh, I know that's going to be on a quadrantal angle. I don't even need to go to my unit circle picture. I can just think about the unit circle, and I can imagine these ordered pairs. Okay, and then remember for cosine, you need the angle from 0 to 2 pi, oops, that's not right, 0 to pi, okay, whose cosine is 1. So when you look from 0 to pi, there's only one spot, it's right here, where you have a cosine of 1, okay, and so you would say that that equals 0. That's 0 radians. Okay, we do that in red. All right, I got cosine inverse of negative square root of 2 over 2. So the answer to this is going to be an angle somewhere between 0 and pi that has a cosine equal to negative square root of 2 over 2. All right, I'm going to use the picture from above. So I know that's going to be right here. Okay, this one would have a cosine of square root of 2 over 2. This one is going to have a negative cosine because I had to go to the left, and cosine has to do with the x direction. And so that's just going to be this angle. So instead of saying pi over 4, I need to go to 3 pi over 4. So the answer to that question should be 3 pi over 4. I could also go to the unit circle and just look. Cosine needed to be negative square root of 2 over 2. And for this problem, I need to be in the first or second quadrants. And so I can report it as 3 pi over 4. That makes sense? All right, let's try tan inverse of square root of 3. Now for this, you have a little more calculating to do. You have to kind of think about where it would have come from. So you do need to think about that tangent came from the sine divided by the cosine. Okay, so you need the angle. Oops, shouldn't be included. You need the angle between negative pi over 2 and pi over 2, whose tangent would equal square root of 3, would be, whose tangent is square root of 3, okay? All right, so, I a lot of times just think about 30, 60, 90 triangles. Kind of depends on how your mind works. And I knew square root of 3 showed up in that one. And tangent is opposite over adjacent. And so square root of 3 is opposite the 60-degree angle. 1 is opposite the adjacent. So this should be a 60-degree angle. And 60 degrees is really pi divided by 3, okay? And pi divided by 3 is what I would want. I would want that angle between negative pi over 2 and pi over 2. So that should be pi over 3. On the unit circle, I can find it, but I have to do a little calculation first because I have to think about dividing, the y by the x. So like here is the answer because tangent would be that divided by a half. And so if you simplify that, you'd get square root of 3. So it would be pi over 3. Okay, hope you're doing okay with this. All right, I got one more to do here. Tan inverse tangent of 1. So I want the angle in that range with a tangent of 1. Now you ought to remember that that's the 45, 45, 90 triangle. It's going to have a tangent of 1 because tangent is opposite over adjacent. So I know it's a 45-degree angle. Okay, you could look at your unit circle and see that. See how the x and the y coordinate of that point are the same. So when you do tangent, you do the y coordinate divided by the x coordinate, you would get 1. So your answer to that should be pi over 4. Okay. So that's going to equal pi over 4. Okay. And then what if it were tan inverse negative 1? Okay. Well, then I got to think about being within here and having a tangent of negative 1. So when you look at your unit circle, you should be focused on first and fourth quadrants. Okay. And here would be where you could get a tangent of negative 1. And so you got to be careful if that were to happen to you. Your answer is not going to be 7 pi over 4. It would be negative pi over 4. It's really important. You would report your answer back as negative pi over 4, not 7 pi over 4, because that's outside. That's outside the range. Okay. So you have to be sure you use the negative pi over 4, not the coterminal angle of 7 pi over 4. All right, so that's the first 6 problems on the worksheet. I want to do 2 more, and then maybe I'll do another one so that this doesn't get too long. Let's go ahead and just use our calculators on the next couple. So, the ones that we did so far, I could just use the unit circle, or I could use special right triangles to answer those. But on 7 and 8, I'm supposed to use the calculator to find the value of the expression rounded to 2 decimal places. So when I'm wanting tan inverse of something like negative 1.9, okay, and they asked me to use a calculator, then I just have to do that. I just have to do tan inverse of negative 1.9. Just make sure you're in radian mode. Okay, and so you just do, let me check that. I'm in radian mode. You just do second tan, so that's inverse tangent of negative 1.9. And then round to 2 decimal places, the worksheet says. So that would be about negative 1.09 if you were to do that. Right? And then problem number 8 on the worksheet has us do cosine inverse of negative 1/3. So you could use your fraction keys there or just use a division sign there. Make sure you're still in radian mode. You should be, unless you changed it, and then do negative 1 divided by 3, or use your fraction key to enter the negative 1/3. And it gives me back 1.91. Remember, these are in radians. Okay. So if you're wondering, hey, that doesn't sound like an angle, that's actually the angle in radians. All right. So that's questions 1 through 8. I think I'll stop the video here, and when we come back together, I'm going to work through some problems that involve composition of functions. Actually, let me show you one on this, and then we'll come back and do more. So here's what's happening next. Next, we're having to do sine inverse of 3/5. So it's like we're composing 2 functions. We're doing sine inverse of 3/5, and then we're winding up doing the cosine of that. Okay, so what's going to happen on this is you're really going to want to draw a sketch of this. So you want to think about it. You want to think about what you've got here. This right here is an angle whose sine is 3/5, and the angle is in the first or fourth quadrants. Right? So sine inverse of 3/5 is an angle in the first or fourth quadrants. Well, for the sine to be positive, it's going to have to be in the first quadrant, isn't it? Okay, so what you're going to do is you're going to draw yourself a sketch. And you're going to put an angle in the first quadrant. I'm not trying to worry about scale right now. I could fix it later if I wanted to. And then I want to label that triangle. If the sine is 3/5, this is the angle, okay? Then the 3 would be opposite and the 5 would be the hypotenuse. All right, so I could find this missing piece right here by using the Pythagorean theorem. I know 3 squared plus this missing piece right here, I'll use an A for that, plus A squared would have to equal 5 squared. So A squared would equal 25 minus the 9. So A would turn out to be just positive 4 because we're talking about a right triangle. Oh, I hate it when it does that. Let's see if I can get, oops. Let me see if I can move that back, see if it'll go back. All right, let me redraw just this one piece of the picture. Okay. Okay. So let me get that coordinate plane back on there where I wanted it to be. And then let me get this out of there. Okay. All right, so that's the sketch you need. Okay. And so now you never actually try to find the angle itself. You're really just trying to get the cosine of that angle. So you're trying to get the cosine of this angle. So now that you have this picture and you know that this is 4 and you're thinking about that being your angle, you know the cosine of that should be 4/5. So the answer to this should be 4/5. So you see how you never find the intermediate value of this? You don't use your calculator to find what the angle is and then do the cosine of that angle. You just use a sketch to figure it out. Let's do one more of these before we do a whole bunch on the next video. Let's try number 10. Number 10 on the worksheet has us do cosine, again, of tan inverse of a positive 1/5. Okay, so we know tan, the inverse tan function should be an angle in the first or fourth quadrant with a tangent of 1/5. So if it's a positive, it has to be the first quadrant, right? So again, on this particular one, you're going to draw your angle in the first quadrant. All right, this is the angle. All right, now tangent is opposite over adjacent. So when you label that, the sides of that triangle, 1 should go there and 5 should go there. So I can find that missing piece, okay, by using the Pythagorean theorem. So I know that this missing piece over here, the hypotenuse, is 1 squared plus 5 squared. So the hypotenuse squared equals 1 plus 25, that's 26. And that means the hypotenuse would be positive square root of 26. Okay, so if I need the cosine, I need to do adjacent over hypotenuse. So it would equal 5 over the square root of 26, and you would rationalize that for your final answer. Okay. All right, so let me stop this. We'll do more of these expressions, which are like composition of two functions, and see how it goes.